In this video, we're going to talk about the graphs of the sine and the cosine functions. Okay, so let's start here with the sine graph. So remember that the sine value, the sine of x, is the y coordinate when you're on the unit circle. Okay, so there's some that we know. So at 0, okay, this point, oops, I wrote it the wrong way. This point where it meets the circle is 1, 0. This one is 0, 1. This is negative 1, 0, and 0, negative 1. So we want to plot some points. So when you have the angle 0, okay, the terminal side and the initial side are the same. So we intersect that point, so the sine value is 0. So we're going to have a point at 0, 0. Okay, now as the angles go to pi by 2, okay, so remember that's 90 degrees, you want to think, okay, what are the y values doing as I go from this point to the top point there? So the y values are increasing, okay, from 0 to 1. So at pi by 2, the sine value is 1. Okay, so at pi by 2, we're at 1, okay, and the values increase in a curve fashion. So it goes like that. Okay, now as we go from pi by 2 to pi, we're going from this point to that point along the negative x-axis. So here, the y values decrease, okay, from 1 to 0. Okay, so then I go back to 0. So at pi, I'm at 0. And I decrease until I get there. Okay, now as I go from angle pi to angle 3 pi by 2, so that's the one, this is 3 pi by 2, so this would be our terminal side. The y values are still decreasing, so the y values are they're negative here, so they decrease from 0 to negative 1. Okay, so at 3 pi by 2, I'm at negative 1, and I decrease until I get there, like that. Okay, finally, as I go from 3 pi by 2 around to 2 pi, now the y values are getting bigger again, so they go from negative 1 back to 0. So at 2 pi, I'm at 0 again, and they increase until they get there. Okay, and then it continues on in this fashion. Okay, so remember that the period for sine was 2 pi. Okay, so from 0 to 2 pi, this is one period of the graph of y equals sine x. Okay, so that's the length is 2 pi there. So some properties about this graph. So the domain, all the x values are valid. So the domain is all real numbers, or negative infinity to infinity. Okay, the range, now the y values are never bigger than 1 or smaller than negative 1. So the range is the interval from negative 1 to 1. So i.e. the y values are stuck between negative 1 and 1. The y-intercept is, of course, at 0, 0. Okay, now there's multiple x-intercepts. Okay, so the x-intercepts are going to occur when your terminal side is here or here, right? Because then the y value is 0. So that's pi. This is any odd multiple of pi. So, for instance, this is 1 pi, or 3 pi, or negative pi. So any odd multiple of pi, and this is all the even multiples of pi. So what we could write, this is, let's say k times pi is the x-coordinate, and the y-coordinate would be 0, and this is for all integers. Okay, so if k is an integer, then we're going to have an x-intercept like that. So 2, if k is 2, I get 2 pi 0. If k is 5, I get 5 pi and 0. Now, since y equals sine x is an odd function, so we saw that in the last video, the graph is symmetric with respect to the origin. Okay, so it's hard to see because we only did one side, but the other side looks similar, okay, but rotated around the origin there. And sine has period of 2 pi, so the graph repeats itself every 2 pi. So on every 2 pi interval you would get a repeat. Okay, so that's the graph of the sine x. Now let's try cosine x. So cosine, remember, here actually I should have highlighted that because this is very important. So the sine x is the y coordinate when you're on the unit circle. Okay, cos x is the x coordinate on the circle. So again, you have these points, so 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So at 0, okay, this is the terminal side. So we intersect this point. The cos value is the 1. Okay, so at 0, we're at 1. And then as we go from here to here, so from 0 to pi by 2, the x coordinate decreases from 1 to 0. So at pi by 2, that's when we're at 0. So we decrease like that. And then as we go from here, the x values decrease some more because now they're getting negative. So they're going from 0 to negative 1. Okay, so at pi, we're at negative 1. Okay, and we decrease to get there. It's going to look, that's not very good. Okay, and then as we go from pi to 3 pi by 2, they start to increase. So the x values go from negative 1 to 0. Okay, so at 3 pi by 2, we're back at 0. So they're getting bigger. And then they continue to increase on this side, so the x values are going from 0 to 1 here. So at 2 pi, we're back up at 1. And it looks like that. Okay, so again, the period is 2 pi. So this is 1 period of y equals cos x is what that would look like. And then it continues. So it's going to go like this. Okay, keep going like that. So again, the domain is all real numbers. Okay, or negative infinity to infinity as an interval. The range is again the interval from negative 1 to 1. So the y values are stuck between negative 1 and 1. The y-intercept here now is 0, 1. Okay, so when x is 0, the y value is 1. And then when we get the x-intercepts, that's when the terminal side is straight up or straight down. So we want to hit these points. So this is pi by 2, and this is 3 pi by 2. So what we want is odd multiples of pi by 2. Okay, so even multiples are going to reduce and give us values, multiples of pi. So the x-intercepts are going to look like k times pi by 2 and 0, where k is an odd integer. Okay, so what you're going to have is the x values are going to be like pi by 2, 3 pi by 2, 5 pi by 2, negative pi by 2, negative 7 pi by 2. Okay, anything that's an odd number times pi by 2. Now cosine is an even function, so it's symmetric with respect to the y-axis. Okay, so you can see, I mean, again, it's hard, but if we had a line here, it would be symmetric about that line. So this side looks the same as that side. Cosine, like sine, has a period of 2 pi, so it repeats itself every 2 pi. Okay, now we can graph transformations of these graphs as well, which gets a bit complicated, but the transformations work the same way, except there's one extra thing that we have to worry about, and that's the period. So if we wanted to graph something of the form a sine of bx or a cos of bx, if b is negative, we can use the even or odd property to get rid of it. So then we can only consider positive b's. Okay, so if b is negative, we use the even odd properties of sine and cosine. Okay, so i.e., if b is less than 0, that means that b is like negative, I don't know, let's say omega, w, and here w is positive, okay, which means that y would be a sine of negative wx. So then we could use the fact that sine is odd to say that this is negative a sine of just wx, okay? Or if you're doing the cosine one, cosine is even, so the negative just goes away. Okay, so we don't have to worry about negatives there. Okay, now if b is positive, which is what we're only going to deal with, it represents a horizontal compression, okay, or stretch, depending on what b is, by 1 over b. Okay, so the period of sine x and cos x is 2 pi. Okay, but the period of sine of bx and cos of bx, so we're going to be multiplying each of the x coordinates by 1 over b. So that means that the period also gets multiplied by that. So the period here is going to be 2 pi over b. Okay, so it just divides by b. Now if b is between 0 and 1, it's going to get bigger. Maybe I'll just write that. So if b is between 0 and 1, then 2 pi over b is going to be bigger than 2 pi. Okay, so this is going to be a stretch, a horizontal stretch. Okay, if b is bigger than 1, then 2 pi by b is less than 2 pi, because I'm dividing it by something that's bigger than 1. So this is a compression. Okay, these are both horizontal. Okay, so just it depends on the value of b. A, if it's bigger than 0, a represents a vertical stretch or compression. Okay, if a is less than 0, so if it's negative, it also represents a reflection over the x-axis. Okay, now the value of what we call absolute value of a, we call that the amplitude. Okay, so the reason for that, let's just draw a graph here. Okay, so I'm going to draw, I don't know, a cosine graph. So it starts up here, goes down, and then, oops, I didn't switch, shoot. Okay, so it goes down, and then to get to the negative bit, and then it comes back up. Okay, and it continues like that. Okay, etc. So what the amplitude is the height from, so here this is like the middle, so I haven't shifted this one. So the height here, this is, it gets as high as absolute value of A, and it also gets as low as absolute value of A. Okay, so that's what we call the amplitude. So another way to say that. So we know that sine and cosine are stuck between -1 and 1. So that means that A times sine x is, so I take, maybe I'll just write this. So the y values, so the sine x values are between -1 and 1. So if I multiply everything by A, I actually want to multiply by the absolute value of A just to make sure that this side is the -1. Okay, so that's stuck between negative absolute value A and positive absolute value of A. Similarly, cosine, so A cosine of x is stuck between these same things. Okay, so that's what we mean by the amplitude. So let's just do an example. So find the period and the amplitude of this. So I'm just going to rewrite this. So this is 5 cosine of 1/4 times x. Okay, so that means that the A is 5 and the B is 1/4. Okay, so the amplitude is the easier one. The amplitude is absolute value of the A. Okay, so that's just 5 here because it's positive. But the period is 2 pi over the B value. So here I would, so 1/4 is between 0 and 1. This is going to be bigger. So this is actually going to be 2 pi over 1 times 4/1. So I'm actually going to get 8 pi here. So the period got horizontally stretched. So the period is much bigger now. Okay, now I'm going to leave part B for you to try. Okay, to figure out the amplitude and the period. Another thing we can do is find the equation for the function. So here, so we want to know the height. Okay, so here it looks like, okay, so this thing, the height here is 3. Okay, and also here is 3. Okay, so the amplitude is 3. Okay, so the period, okay, so here it looks like, so from here to here, okay, that looks like the sine graph. Sort of. So it kind of looks like the sine graph. But that is, so it goes down and then back up. Okay, this is one period. Because it's going to repeat again after that. So that means that P, the period, is 20. Okay, so the period is 20, but it should be 2 pi over B. So we can use that to solve for B. So B is going to be 2 pi over 20, which is pi over 10. Okay. Now I'm going to assume this is the sine graph. So normally the sine graph goes up initially. Okay, so because it goes, it's down, it's been flipped. Okay, so this graph, actually I'm going to write, if we assume this is y equals a sine of bx, okay, then it must have been reflected over the x-axis. So that means that our a value should be, negative. Okay, so we knew that the absolute value of a was 3, but it actually means that a should be negative 3. Okay, so our equation is going to be y equals negative 3 sine of pi over 10x. Okay, now how did I know it was reflected? Because the sine graph normally goes up and then 0 and then back down. Okay, so this one did the opposite, so that's why it's a reflection over the x-axis. So that's why my a value should be negative. Now, to graph something like this, you can use transformations, okay, or you can try and break it down. So find the period, divide the interval, so do 1 period into 4 subintervals of equal width, okay, and then we're going to use 5 key points. So that is like the 5 points on the unit, so there's 4 points on the unit circle, but you use the first one twice. Okay, so to find the y-coordinates, we use a. So if it looks like these, then the y-coordinates, so think about where the sine value would be 1, and because of the a, it's actually going to be a. Similarly, where the cos values are 1, so they're giving it to you in the order here. But let's just do an example. And actually, I'm going to skip this one and do the next one. So we want 2 cycles of this graph. So the first thing we want to do is find the period. Now, cosine is even. So if they want me to graph this guy, 2 cos of negative 4x, it's actually equal to 2 cos of positive 4x. Okay, because cosine is even. So we can just ignore that negative. Okay, then the period is going to be 2 pi over the b value. So maybe I should just write. So a here is 2, b is 4. So 2 pi over 4. So that's going to be pi over 2. Okay, now they gave me 8 things here. Okay, but so 1, 2, 3, 4. So after 4 steps, that's going to be my period. Okay, so then 4 more steps, 1, 2, 3, 4. That's going to be double my period, which is going to be pi. So then 2 pi in half is pi by 4. Okay, so this one's going to be 3 pi by 4. And then half of that, this is actually pi by 8. Okay, so then this is 2 pi by 8, 3 pi by 8, 4 pi by 8, 5 pi by 8, 6 pi by 8, 7 pi by 8. Okay, so that's how I would break this down. And then for cosine, okay, so, well, first of all, I guess, so my a is 2, so that means that the range for this is not -1 to 1, it's -2 to 2. So wherever cosine is 1, okay, wherever cosine is 1, it's actually going to be 2. So what our graph is going to look like, so at 0, cosine is normally 1, so it's going to be at 2. And then by the first step, it normally gets to 0, and then it goes down to -1, so that's down to -2, and then it goes back up to 0, and then back up to 1, so in this case 2. So our graph, this is 1 period, is going to look like that. Okay, so from here to here, this is 1 period. So it wanted us to do 2 cycles. Okay, so that's 2 periods. So this is a second period. Okay, or cycle. So again, it's up at 1, and then it goes to 0, and then it goes to -1, or -2 in this case, and then back to 0, and then back up again to 2. Okay, and it just continues like this. So it would go like that. This one's going to go like that. Okay, and that would be our shifted, so stretched in this case, graph of cosine. So maybe I should just write here. So this one has been vertically stretched by a factor of 2. Okay, and horizontally compressed by 4. So I said compressed, so it's probably a factor of 4. Okay, but basically you took your x and you times it by 1/4 to get your new x. Okay, so for this one you took the y values, okay, and you times them by 2 to get the new y values. So that's how we could graph. Now again, I'm going to skip this one. And in fact, I'm going to skip the other 2 as well. Actually, that's a lie. I'm going to do one more. Okay, so let's skip number 6 and do number 7. I wanted to leave it for you, but we haven't done one with a vertical shift either. So here, for this one, my A value, is 4. The B value is pi by 2. Okay, so then we can find our period. Oops. So the period we normally call P. Okay, and it's 2 pi over B. So that's over pi by 2. So that's going to be 2 pi times 2 over pi. So it's actually going to be 4 here. Okay, so P is 4. So we're going to split this up into, we want 2 cycles again. So I'm going to go find where. So after 4 steps, okay, so 1, 2, 3, 4. This is going to be where the first period is. So that's going to be 4. Okay, because this is 1 cycle. Okay, and then 4 more steps. So 1, 2, 3, 4. That's going to be our second cycle. Or period. Okay, so that's going to be at 8. So then we want to divide this into bits. This is easy because our number is 4. So this is just going to go up by integers. Okay. So the amplitude is 4, but this bit up here, okay, so this is a vertical shift. So we're going to go down 2 units. Okay, so that means that our middle is actually going to be here. Okay, so that's where our zeros are. So this is where we place points that are zeros in y equals 4 cos pi by 2x. Okay, so that's where we place the 0 ones. And then the amplitude is 4. So we're going to go up 4 from that middle bit. Okay, so initially at 0, cosine is a 1. So that means I actually want to be 4 above that. So my point is going to be there. Okay, so this is where my point is. So that's going to be at 0, 2. Okay, and then by the first move, Okay, by the first quarter, I'm at 0. So that's going to be at -2. And then by the next one, I'm down 4. Okay, so I'm going to be at -6 down here. Okay, so this is 2, -6. And then by the next quarter, I'm back up at 0. And then I'm back up at 2. Okay, so my graph is going to look like, so this is one period of my graph. Okay, so this is because it was vertically shifted, that's why we had to move sort of the middle of the graph. Okay, so again, this distance here, this is my A. Okay, so that's 4, and this is 4, because the amplitude is 4. Okay, so from the middle, which gets shifted vertically here, from the middle, we want to be 4 above and below for the highs and the lows. Okay, and then we can continue. So by 5, we're back at 0. By 6, we're back at -6. By 7, we're back at 0. And by 8, we're back at 2. So now once I draw this, I'm going to have 2 cycles of this graph. And it's going to continue like that. Okay, so that's 2 periods of this graph. So the vertical shifts, you just move the center of the graph. You can also do horizontal shifts, but we don't normally do that when there's something involving the period. So like before, we never combined the horizontal stretches, compressions, reflections with the shifts. Okay, so we won't do that here either. We just do them one at a time. Or not right away anyway. So we might do that later on, but it takes a bit of extra work. Okay, so we want to be careful about that. So for now, we won't be combining with the shifts yet. But the vertical shifts, all you have to do is just move the center, however many you vertically shifted. Okay, so that's the idea. Try and complete those other examples. Now notice this one is actually number 6 is very similar to number 5. So you might be able to save yourself some work if you just notice how they're related. So those are the graphs for the sine and the cosine and some transformations of them.